Hello. So hope you can. Hello. Yeah. So module 2 is about two sample hypothesis testing. What is two sample hypothesis testing? So let me explain briefly about the concept, what we are going to do, and then we'll do some practice on Minitab. So as you have done previous course, BADM 503, there you learn one sample hypothesis testing. Here we are going to do two sample hypothesis testing. So let's see. Let's see, you have a problem. A problem is that you want to compare the public universities professor salaries in Washington and California state. Who is earning more, who is earning less? So basically you want to see, you want to check how you can do that. Or suppose you want to do any other comparison. However, make sure you are comparing. Comparison must be between apple to apple. It should not be any comparison that cannot be properly designed. For example, I'm giving an example. Public university professors salary between India and USA. It cannot be compared. Reason is that India professor salary is like $1,500, and US professor salary is about $10,000 per month. So that cannot be compared. What you can compare? So suppose you want to compare the salary of Indian professors and US professors, what you can do? You have to design it properly. That means you have to adjust the salary based on purchase power parity, or it is called PPP, or different indexes are there. So basically it has to be designed correctly that you can compare. You can't compare apple to orange. Here you have to compare apple to apple. Now what is the process in order to do that? First step, you have to make the hypothesis, or it is called. So basically whenever you make a hypothesis, you make a set of hypotheses. So H0 is called null hypothesis. Null hypothesis is U1, or basically this is mu, the sign mu, but here I don't have on keyboard, so I'm just going to write, and mu2. What are the mu2 and mu2? So mu1 is public university professor salary. So I can say U Washington minus U California equal to 0. That means they are same, therefore it is 0, means mu of. And then second alternative hypothesis would be, or I can say a alternative, you can write a or you can write symbol 1, either way both are correct. U or mu Washington minus California not equal to or not equal to 0. So this is two hypotheses that you have selected. I mean, you have framed. Now, you can also make the hypothesis that, here null hypothesis, you can make University of Washington University professors earn more than university, more or equal than California. And then what would be the alternative hypothesis? University of Washington professor earn less than. So this is second set of hypothesis, null hypothesis. And this is third set of hypothesis could be University of California. So basically it could be reversed. So University of Washington is less or equal to University of California, and the H1 HA University of Washington is more than University of California. So these are the three situations where you can have more, less, equal. So now what is the second step in order to do? So basically when you do the assignment, you have to follow these step by step process. Second step is again based on what kind of confidence interval, what kind of significance level. So basically decision rule that, at what level of significance, which is alpha, or you can say alpha or 5%, 0.05, or otherwise you can, or you can say confidence interval, confidence level 95%. So basically, what is the third step in this? The third step, you are going to collect the data that has been already provided with the assignment. So you have the data which is ready-made. So you are just going to include the data in Minitab and you are going to run the hypothesis testing. Collect the data. How you can collect? Basically, you go in public university of, uh, or you can get the data from open source. Nowadays, government data is available openly. So you can go on Washington State professor's salary and you can get, the professor's salary from Washington State. You can just find in particular area, let's say sociology, or you find in psychology or business management. And similarly, you can get the California State professor salary. So using government data or open data of government, you can get the data. Let's say you got sample of 200 from each state. The fourth step in this, calculate the statistics. So basically, it we can get directly outcome from. So we get directly from Minitab. And fifth decision, fifth step is make your decision. So if significance or alpha level is p value is equal and more than alpha level, then then alpha or significance level, then your null hypothesis is accepted. Just a minute. Then your null hypothesis is accepted. That means what you will say? That, there's no difference between professor salary of Washington State and professor salary of California State Universities. Suppose it happens, if you see the p value is less than the significance level, then what you will say, your decision would be there's a difference between professors salary in Washington and California State. So this is the process in order to compare two sample. The two sample hypothesis, this is the process. Now let's go back on slide. Here, one more thing, as you learned in the past class, there can be three ways just a minute. There are three. So basically, this is based on mean. Similarly, the hypothesis testing can be based on. So first is based on mean. It could be based on proportion. Proportion. It could be based on variance. Variance is we use chi-square test. This is proportion, this is mean, this is, and it's also based on pair sample t-test. Oh, sorry, pair sample means you are taking a sample from same population in different situation. For example, pre or so, if you are going to take the study of pupil before education and after education. So basically, these are the two situation, two pair with same sample or same population. So before, after you do longitudinal or other kind of thing. So basically pair sample is in two different situation within same population that you are going to take the sample. That is called pair sample. So these are the ways to test two sample hypothesis. Now look into so two sample tests comparing two means independent samples. So here confidence interval for difference of means, comparing two means, paired sample, comparing two proportions. So basically this is a paired sample where you have taken two proportions, and confidence interval for two proportions and comparing for two variants. So this is what we are going to learn in this. So two sample test. So basically you have mu1, you have mu2, two samples, and what you are going to say, both samples are equal. Therefore, the difference between mu1 and mu2 is going to be 0. And that is what is our hypothesis. So what is the process? State the hypothesis that we just learned, set up the decision rule, 95 or 5% significance or 10% significance or 1%. Insert the sample statistics, the sample data that you have collected, make the decision based on critical values or using p-values. So both are the ways to do that. And so basically left tail test, two tail test, right tail test, like I just explained. D0 is the difference in the means. So basically difference is 0, difference is no 0. So like I said, so mu1 minus mu0, mu2 equal to 0, which means no difference, and D0 is not. So here also you have just so as you remember the last 503, there are two cases when you compare the mean. When you have the standard deviation known or variance known, then you are going to use Z statistics. And if you don't know unknown variance, assume equal, and then you are going to use T distribution. So, and assuming the population variances are equal can be used to estimate common pooled variance. So this is just like, one sample test we are going to use. Case third, unknown variance assumes unequal. If the unknown variance are assumed to be unequal, they are not pooled together. In this case, the distribution is different. So basically, how do we know? Use the WAG, this statistics. And so we are going to check this. So the formula will be all different in all cases. Known variance, unknown variance, assume equal, and unknown variance assume unequal. So these are the three cases that we are going to deal with. State the hypothesis, specify the decision rule, calculate the test statistics, make the decision, and take the action. So basically, exactly those steps I just explained. Now we are going to work on some problems. So this is our mini tab. How do we go here? Go under statistics. Under statistics, you have basic statistics. Under basic statistics, you have two sample t-test. What you have? Two sample t-test. You have pair test. You have pair t-test where you have two situations before, after. This is two proportions test, and here two variance. So basically here you have what we are going to use: two sample t-test, pair t-test, two sample, uh, two proportions and two variance. These are the cases we are going to use. Now here we have the data of two pharmacies. One is in Colorado, second is in Texas. Now I'm going to compare with, I don't have the population standard deviation or variance known. So what am I going to do? Here I am just going to do statistics, basic statistics. I'm going to use two sample t-test. Now here you have both the things. You can do both the samples are in one column, each sample in one column, or summarize data. So basically in summarized data, sample size, sample mean, standard deviation, all these things you are going to put for sample 1, sample 2, sample. But I have the data right here, so I'm just going to use sample 1 is in C2. Okay, here is the situation. So I have to fix the data here. This is, so I am going to remove this. Basically, I'm going to remove this because otherwise it was not. And now, so I have now clear. So basic statistics, two sample t-test. And now C6 is our Colorado one. I think I did. No, something again has been done wrong. So basically what, here let me go with, this is just format cells, and this is just not text, this is just number. So and this is also number, because it was a text, so text is not analyzed using Minitab. So now we have numbers. Now I go on stat basic two sample, and now I have C2 here, which is Colorado, and C4, which is, now I have the options here by default, 95% confidence level. That means 5% significance, which comes directly, automatically Minitab takes 95% confidence level and 5% significance level. Here, this is, always remember the alternative hypothesis is here, null hypothesis. Minitab doesn't get the null hypothesis. Therefore, we need to always put alternative hypothesis. So all three symbols are, so let's take, we are checking equal or unequal. So basically this is unequal. Here we have assume equal variance or don't assume. So let it be, I'm going to, and now, okay, here, so my first sample is in C2 and the second sample is C4. Options are right there, and now I'm going to do it. So you can see these are the descriptive statistics number. Now look into the difference is mu1. What is the alternative hypothesis? Mu1 minus mu2 is 0, mu1 minus mu2 is not 0. So basically this is the alternative hypothesis. Based on this calculation, what we can assume, what we can conclude. So look into here. So this is confidence interval. I'm not going to talk. Let's talk about this. This is the test statistics. Here t value is this much, degree of freedom 24. P value, how much is p value? P value is 37.6%. So p value is 37.6%. And what is the alpha value? As we know, we took 5%. So what is your p value is greater than alpha value? Then what you can say? Very simple. If p value is greater than, so 37.6% is greater than 5%. Therefore, what we can say? Null hypothesis is accepted. Or in other word, technical word, we fail to reject null hypothesis. That means what we can conclude, what would be our decision? The Colorado and Texas pharmacies have no difference in mean. So basically, we can conclude this way. So this is the conclusion based on the hypothesis testing. Let me do one more example for this and then so just a minute. Let me pull out one more. So this is another example and you can clearly see what kind of example is this. This is basically a weight loss after and before. So before it was this, after it was this. So somebody who did, workout, what kind of weight loss? So Mickey got 14.5 pound weight reduction. Somebody got, so basically before and after workout. So what is this case? This is statistics, basic statistics. This is paired sample t-test because what we are doing here. So here each column in, so you can take a 2 column. Sample 1 is before, sample 2 is after. Again, you can put the options here, or here we have the difference. You can summarize data, or you can choose the, so each column, options, difference is not equal. And now I'm going to do the calculation. So what we got, I think I need to, so here you can see before is this, after is this. So before is this, after is this, t value is 9.01, p value is 0. So how do we conclude here? Is there a difference? So let me again put this. So p value is 0 and alpha value was 5%. So here 0 is less than 5%. That means what you can say? H0 is rejected at 5% level of significance. Therefore, hence, we accept the alternative hypothesis. That means there is a difference before there is a significance difference before and after workout weight. So this is, since based on the data, based on 5% level of significance, we are concluding there's a significance difference. Means one can observe if somebody does the workout, there's a significance. So this is based on. Now, similarly, we can go with, let's say, I'm just going to use the same data here. I'm going to use so now I go on statistics, basic, 2 variance. And so I'm just going to, so sample 1 is C2, sample C4, and now I'm going to option here. We have hypothesized ratio is 1, 95%. Again, alternative hypothesis ratio is hypothesized ratio. So I'm going to here you can see this is statistics. Now look into that. Why we call it? So here hypothesis is written in this form. When you are checking the sigma square or variance. So sigma square or variance of Colorado and sigma square is Texas. They are equal. If both the variances are equal, that means it would be 1. So this is the hypothesis. Alternative hypothesis would be sigma Colorado square divided by sigma Texas square not equal to 1. So this is the way, significance level 5%. Now look into the, again you see the p-value. So here is bonnet, here living. Look into that. What is the p-value here? P-value is greater than the significance level in both the tests. Therefore, you can conclude that sigma C square or sigma Colorado, or there's no variance, there's no difference in variance in Colorado and Texas pharmacies. So this null hypothesis is accepted because p-value is greater than 5% in both the tests using methods, and so we fail to reject null hypothesis, and this is accepted. So basically, what is the important task here? Let me make it very clear. What is your task when you are doing any numerical? So what is your task? Means how you can go. Number one step, which test needs to be means selecting the right, for example, either t test or pair test or proportion test or the variance, what is asked. So this is very first thing that you are going to look into numerical. The second thing you are going to look into the you are going to write null hypothesis and alternative hypothesis both. The third step, what you are going to do, decision rule, means 5% or 1% or whatever percent. So what is the fourth step? You are going to have the data is already provided, so you are going to put the data or insert the data. Data is given normally not in summarized form, data is given in the form of tables. So you are going to select the column. So data is given in table or raw data or sample in sample form, or if not given, or if given in summarized form, so you are going to choose the right option under the mini tab or summarized form. So you are going to deal with both the things. Fifth option, you are going to look p-value, and p-value is higher, then null hypothesis accepted, p-value is lower, null hypothesis is rejected. The sixth, you are making decision. This is widely applicable in many management decisions. So suppose you want to consider the sales of 2 stores. Is there any difference in the sales of 2 stores? So basically you are having the data of 2 stores. Suppose you just take a random data of 2 stores, or of like 30 observation of store 1, 30 observation of another store, and you are going to check this. Suppose you are going to compare the quarterly. I'm giving an example. Let's say you are going to compare a case of, let's say, the sale of 7-Eleven stores in Washington is higher than 7-Eleven stores in Idaho. Then what you are going to do? You are going to do the sample of 7-Eleven sales record of Washington State, 7-Eleven sales record of, randomly sample of some stores from Washington, from Idaho, and then you are going to compare. Similarly, you can do a case of salary of, or you can do, salary of IT employees, particularly employee, because there is a wide range of employees, or you can say IT developer or software developers in Seattle Seattle area, and Silicon Valley. So basically, you are not going to compare, someone who has 40 years of experience or someone who has 10 years of experience. Basically, what you are going to do, you are going to do a random sampling of software developer randomly in Silicon Valley, in Seattle area, and then you are going to check. And then you also conclude who is having higher salary, who is having lower salary. So this is what you can do using two sample hypothesis testing. Okay. So similarly, t-test, similarly p-test.